Hello students. Today we are going to talk about solutions. You are familiar with solution? Actually, there are majority of the reactions in the laboratories which are taking place in the form of solutions. So let us discuss about solutions. Examples of solutions which you are familiar, that is when you add salt in water, it gives a homogeneous mixture, that is a solution. Similarly, sugar in water, alcohol in water, these are the examples of solutions. You can find further examples also, so you can add in this list. There are two components of solution. Component present in the small proportion is called as solute, and the component which is present in the large proportion is called as solvent. So that means whenever you are comparing the solute and solvent in a solution, it is always compared that the component which you are adding, which is present in the small proportion, is the solute, and which is present in the large proportion, that is solvent. Solute and solvent, which is mentioned in the figure here, the particles, you can see these are the solute particles and the solvent particles is the liquid which is taken. So when you take an example of a salt solution, in that salt is the solute and water is the solvent. A solution can have more than two components also. For example, if I am adding sugar, salt, both in water, in that case we can say that there are three components, that is sugar, salt, water. So basically we will consider the two components of two components of solution, which are solute and solvent. The component which is present in the small proportion is called as solute, and the component which is present in the large proportion is called as solvent. As in the figure, it was shown that the particles which is present here, these are the solute particles and it is present in the solvent. So we can say that the two components of solution are solute and solvent. While expressing a letter for solute, usually we represent solute by capital B and we represent solvent by capital A. What about the concentration of a solution? Let us do a demonstration. Take 1 gram of salt and add in 1 liter of water. Take the same quantity of salt and add into 1000 liter of water. Now if I tell you to taste both the water, that means 1 gram of water which you have added in 1 liter and in 1000 liter. So definitely it happens that you will not feel the salt taste in the water in which you have added 1000 liter of water in which you have added 1 gram of salt, because in compared to the 1000 liters 1 gram of salt is very small. So that means the concentration was very less in the case of 1000 liter of water. So that means the concentration of a solution, actually it is the amount of the solute present in a given quantity of a solvent or a solution, that is expressed as a concentration. So in this example we can say that higher the concentration in 1 liter of water when we add 1 gram of salt in compared to the 1000 liters. Concentration of a solution can be expressed in any of the following ways. These are molarity, molality, mole fraction, mass percentage. So let us discuss these terms in detail. Molarity. Molarity of the solution is defined as the number of moles of solute dissolved in 1 liter of solution. 1 liter means 1 decimeter cube of the solution. It is denoted by capital letter M. So how we find out the molarity of the solution? Number of moles of solute divided by volume of solution, and that you need to take in terms of liter. So let number of moles is represented by small letter n, and capital V is the volume of the solution in liters. So formula for molarity of the solution is equal to N by V. As N, number of moles can be calculated by the formula, that is given mass by molar mass, as we have discussed already. So in the place of N we can write mass of the solute divided by molar mass of the solute, that is given mass by molar mass. So N is equal to W by M, where W is the given mass, M is the molar mass. So when we are substituting this value in this equation, we are getting this equation, that is W by capital M into V is the molarity, where W is the given mass, capital M is the molar mass, and V is the volume. So this is give rise to concentration, that is molarity, and molarity is also represented in terms of capital M. Let us check what is the unit for here, because we are dividing number of moles by volume. So unit for number of moles is moles, and the volume we are representing in terms of liter. So the unit for molarity is moles per liter. Let us talk about molality. You can find the difference here. It is lity. In the previous one, it is riti. This is molality. Molality is defined as the number of moles of solute dissolved per kg of solvent. That means here we are taking number of moles of solute divided by the mass of solvent in kgs. That means in the previous one we are taking volume of solution, but here we are taking the mass of solvent. And when we are taking the mass of solvent in terms of gram, at the time you have to multiply with 1000, because always the molality is expressed in terms of mole per kg. So what is the formula for molality, which is represented by small letter m? Small letter m is equal to number of moles of solute divided by the mass of solvent, that means W, mass of solvent in kgs. But whenever it is given in gram, you need to convert into kg. Therefore, we are multiplying with 1000 when the mass of solvent is given in grams. Next is mole fraction. Mole fraction is the ratio of number of moles of one component to the total number of moles present in the solution. It is expressed in terms of X. That means if you want to find out the mole fraction of solute, you have to find it out by formula, that is moles of solute divided by total mass, total moles. That means here total relates to both solute and solvent. So that is number of moles of solute divided by total number of moles present in the solution. That means moles of solute plus moles of solvent give rise to total moles present in the solution. But when we want to find out the mole fraction of solvent, at the time the moles of solvent divided by total moles present in the solution, that is moles of solute plus moles of solvent. And it is observed that mole fraction of solute plus mole fraction of solvent is equal to 1. When you make the sum of mole fraction of solute and mole fraction of solvent, you will be getting 1. You can check this one. When you make the sum of these two, you will be getting 1. So let us write the formula for molarity, molality, mass percentage and mole fraction. So first, in the case of molarity, as we have discussed, it is the number of moles of solute present in 1 liter of solution. It is very important, 1 liter of solution. That means we are taking the volume of solution here and in terms of liters. So that is the molarity is equal to N by V, where V is the volume of solution and it should be taken in terms of liter. Next, molality, that is number of moles of solute dissolved in 1 kg of solvent. That is the mass of solvent and it is expressed in terms of kg. But in the case molarity, if the volume is given in ml, at the time you have to multiply by 1000. In the same way, in the case of molality, if the mass is given in terms of gram, you have to multiply with 1000. The next one is mass percentage. How we find mass percentage? That is mass of solute divided by mass of solution into 100, because we are finding out the percentage. Next, mole fraction. That is if we are finding out the mole fraction for A component, then we can say the number of moles of A divided by number of moles of solution. That means number of moles can be represented by N. So we can say that Na by Na plus Nb, where Na is the number of moles of A component and Nb is the number of moles of B component. So these are the formulas which we are using to find out the concentration of solution in different ways. Either we can find out the concentration in terms of molarity or in terms of molality or mass percentage or mole fraction. So in this way we have finished the portion, that is reactions in solution. Problems based on these topic will be discussed in the next video. So thank you everyone.